Hello everyone, I am Mustafa Ghiyasman with the second session of Introduction to ArcObjects using C#. From the previous session, we have some experiences from working with ArcObjects Developer Help and reading object model diagrams. In this session, we try to have a closer look at object model diagrams and translate various kinds of symbology, including different classes and relationships. Okay, let me open the ArcMap object model. Here is ArcMap object model. Object model diagrams are useful tools for exploring the relationship between classes. And it is obvious that it is impossible to put all the ArcObject classes into one diagram. For example, for ArcGIS 10.4, there are 68 object model diagram and they are organized with the topic. And it is nice to say if you write something with ArcObjects, for example, version of 9, it also will work with the now version of 10. Because ArcObjects are based on CAM components and they're guaranteed not to change. And your programs will work from version to version. Okay. An important skill for ArcObjects programmers is the ability to identify objects required to perform their programming tasks. As a result, navigating to object model diagram is a key part for us. Diagrams are drawn with unified modeling language. UML is made of many symbols, but you only need to know some of them to really navigate navigate your ways around the diagrams and start to write some code. Each of the diagram, like this, has a legend, symbols to help us understand how to read diagram. And I'm going to explain what all these symbols mean in the legend so you can read the diagrams and learn to write some code. To have a good understanding of ArcObjects, it's vital to have knowledge of object-oriented programming language. Class, like report class, may be thought as a blueprint of creating objects. The blueprint determines what properties and methods an object of the class will have. Although they are sometimes used interchangeably, a class and an object are different things. A class defines the type of object, and it's not an object itself. And an object is an instance of a class. A rectangle is a very simple graphical representation of a class. It has three sections: the name of class, properties or the attributes, the method or behaviors. Let's start with our first kind of class, which is abstract class. Abstract class is shown as a two-dimensional box shaded in. Abstract classes mean you cannot make any objects of these classes. The abstract class is really just there for inheritance purposes. An obvious example of abstract class is layer class in cartoon namespace. And then here, page of tree, and then zoom in, and here is layer class, which is abstract class, two-dimensional box shaded in. Layer class is an abstract class, so we cannot create objects directly from the layer class. You might be saying we can see layer objects in ArcGIS, but they are not layer objects. They are a specific type of layer, like vector layer, base map layer, or raster layer. 3D box, but not shaded, is a symbol of class. You cannot make objects out of these classes. And other objects have to do the creation for you using instantiation relationship. Co-class is other type of class in ArcObjects model diagrams. Co-classes are shown on the diagrams in the three-dimensional box and shaded in. When you see a co-class, this means you can create objects from these classes. Map class in cartoon namespace is a good example of co-class. In the first page of cartoon namespace, here map class is a co-class. And we know map class is a class of data frame in ArcGIS. As an ArcMap user, we can create and add data frame easily because the class of data frame in ArcObjects, which is a map, is a co-class. And as a developer, we can create a map object, which is a data frame, just by 2 lines of code. All classes have properties on them shown with the barbell symbol. Some of the properties have a left-sided barbell. The left-sided bubble means you can only get the value, but you cannot change it to something else. Some of the properties are called write-only properties. They are shown with a right-sided barbell. You can edit the value, but you can never find out what it is. Some of the properties are empty right-sided barbell. You can put the value, but only by the pointer of the object. Classes also have methods. Methods are shown with the arrow symbol. Methods are like the actions that an object can perform. In a report class, we can see the list of properties and then a colon after the name of property with a suggested data type. This is the value that property holds. Some of the properties hold the basic data type like numbers, strings, and Boolean values. Some properties will hold the object or reference to objects. For example, extent, layer, selection set, and table. Properties. Also, it is quite common to see parentheses containing any parameters after the name of methods, and then colon after parentheses to determine return type that is expected to come back from these methods. Also, some of the properties and methods use Esri enumeration type. For example, export report take a parameter of Esri report export type enumeration. And here are the values. As a user of ArcGIS, every time you use the ArcMap application, you are working with Esri enumeration types. For example, when you use select by attribute window, you have to choose one of the selection methods, and this is one of the Esri enumeration values. There are plenty of Esri enumeration types in ArcGIS applications. Classes use interfaces to organize their properties and methods. For example, here report class implements 3 interfaces, and we say a class implements its interfaces. And there is a naming convention with interfaces in ArcObjects. The name of interfaces begins with I. And we say iReport data source, iReport engine, and iReport template interface. Look at here. There are three main rectangles in the UML of report class. Here and here for report engine, and here for report template interface. These properties are declared in iReport data source, and in these two methods are declared in iReport engine, and again here. And there is a main point here. In interface-based programming, we don't use objects directly. Rather, we access the members of class through the implemented interfaces. For example, if I want to have access to layer property, I have to have an object that points to iReport's data source interface. And again, if I want to have access to run report method, I have to have an object that points to iReport engine. Another main point that needs to be taken into more consideration is classes use interfaces to communicate with each other. For example, from the previous session, we learned how to access to a mixed document class in ArcMap UI by using document property in application class, which returns a reference to a document interface. And we know a document interface is implemented by a mixed document class in ArcMap UI. And again, ArcMap UI, and then zoom in, and a document interface is implemented by a mixed document class. There are plenty of examples in ArcObjects that use this technique. In report class, the first property returns a string, which is a basic data type. Second property returns a reference to a geometry interface, which is implemented by a geometry class. Layer property returns a reference to a layer interface, which is implemented by layer class. Selection set, iSelection set, and table, iTable, which are implemented by selection set class and table class respectively. Let me to show you selection set example. Selection set property returns a reference to iSelection set. To find selection set class, which is in geodatabase reference, geodatabase object model. Here is selection set, which implements iSelection set. As a consequence, interfaces play a vital role in ArcObjects programming, and it's essential for you to have a good knowledge of interfaces. Another main point is different classes can implement the same interfaces. For example, the query filter class implements iPersist stream, and record set class implements iPersist stream again. At first, it looks a bit confusing, but using these techniques, we don't need multi-inheritance, which is an advanced topic of object-oriented programming. Sometimes we see the name of interfaces with additional numbers, for example, 2, 3, and so on. Here iSelection set, and again iSelection set 2. iQuery filter, iQuery filter 2. iQuery filter definition 2. Again, iRecord set 2. These are because once an interface is created, it can never be updated to provide additional functionality. For example, Azure developers were forced to implement iSelection set 2 in order to add additional update method into selection set class. There are two types of interface in ArcObjects, which are shown with a lollipop symbol. Inbound interfaces and outbound interfaces. Inbound interfaces are our usual interface in ArcObjects, while outbound interfaces are related to events. Events like open or close a map document, add a layer, or change a selection. To be more precise, let me give you an example in ArcGIS. Outbound interfaces play a vital role in ArcMap application. For example, when I open the Select by Attributes window, the layer list is exactly the same with the vector layers in the active data frame. Cities and countries, cities and countries. And when the window is still open and I add another vector layer like rivers layer, the layer list will be updated automatically. And again, when I remove it, the layer list will be updated. These capabilities is all because of events outbound interfaces. Let me to show you another example. When I open the attribute at table of cities layer and then select some cities, the number of selected cities is shown here. And again, and this is because of outbound interfaces in ArcMap application. In the first page of Carto namespace, you can see map class, and there are some outbound interfaces like dynamic map events, iActiveView events, and iMap events. If you want to add a user interface to ArcGIS like select by attribute window and your list will be updated automatically, you have to implement some methods like item added and item deleted. Let's continue with different types of relationship in ArcObjects. I mean inheritance, instantiation, composition relationship, and association. One linear symbol is called association, and sometimes we see association relationship with multiplicity. A good example of association relationship is with map class, the relationship between map class and map surround. Map surround means legend, scale text, scale bars, with a multiplicity of 0 to many. There is map class and map surround in the Carto map elements. Composition relationship. The compose of symbol is shown with a solid diamond. Compose of means the object with diamond is composed of other objects. This means if you delete the object, composed of object will get deleted also. A good examples of composition relationship we can see in ArcMap application. We know if we close the map document, for example, new document or open the document, all the data frames in the document will go away. So the relationship between map document and data frames should be composition relationship. And also, if we delete a data frame, remove the data frame, all layers in the data frame will get deleted also. So the relationship between data frame and layers is also composition relationship. And here in ArcMap UI, you see relationship between mixed document, which is a map document in ArcMap, and map, which is a data frame in ArcMap, is a composition relationship. And in the cartoon namespace, relationship between map class and layer again is composition relationship. Let's continue with other types of relationship. ArcMap UI and instantiation or creates relationship. A dashed line and an arrow indicate a creates relationship or instantiation relationship. Here, one object creates other type of object. An example of instantiation relationship could be seen in the geodatabase object model. And let me to zoom in. Workspace factory class and workspace class, and the relationship between two classes is instantiation or creates relationship. Workspace class is a 3D box but not shaded, so we cannot create an object directly from workspace class, and other class have to do it for us. And workspace factory class creates an object of workspace class for us. For example, here by using open or open from file method, we should in iWorkspace and iWorkspace, so we can have object of workspace class. Let's continue with the last type of relationship in ArcObjects, which is inheritance. Inheritance is shown with a triangle, empty arrow pointing at a superclass, and all subclasses inherits all members of the superclass. A clear example of inheritance is layer class. In cartoon namespace and page of 3, and here is layer class inheritance relationship. All subclasses inherit all members of layer class, and layer class here is superclass. To have a better understanding of UML symbols in class diagram key, let me to give you a short overview of using UML tool diagram in Visual Studio. I open the Visual Studio and then new project. I select Windows application, Windows Form application, name of project, UML diagram, sample, okay. And then right click on the name of project, add and select new item. Search diagram tool, class diagram, UML class diagram and then add. Okay, here we have class designer toolbar with some controls like class, enum, interface, abstract class, and inheritance, association. Consider an example of university. Generally, we could say there are two types of people in university, employees and students. For employees, we can add a class with the name of employee and then OK. And for students, add a class of students and then OK. Now we can add members for each class. For employee, add a property of first name, the type of string, and then add another property for last name, the type of string, of course, and add another property of employee ID, EMPID, the type of integer, and some methods, for example, access for employee. And for student class, add property of again each student have first name, the type of string, and again last name, the type of string, and each student has a student ID. I call it CID, the type of integer, and some methods like apply, for example, and another method for register. Okay. You will notice if your classes start sharing common behaviors and attributes. Say in this case, we realize we're sharing first name and last name. So we may then create a superclass, but I call person with all similar members in the superclass. So all the classes inherit common members from the parent class. Let me to add a abstract class for person because I don't want to create an object directly from the person class. Just the purpose of inheritance. And then put first name property, again the type of string, and last name property, the type of string, and then remove the common behaviors and attributes into the subclasses, first name and last name, and then all the subclasses inherit common members from the superclass. Inherit relationship, employees from person, and again students of person class. So now all the subclasses has its own of members with the members from the superclass. I add abstract class for person class because I don't want to create objects directly from the person class. And remember, like a layer class in ArcObjects is abstract class because we don't want to create object directly of layer class. If you want to use interfaces, you can add an interface, for example, with the name of iPerson, here, and the food, and declare members in add property interface, and then second last name into the name of string, and again last name with the name of type of string, and then remove common behaviors from the abstract class, and then with the inheritance relationship we can show the relation between person and a person class, and we say person class implements a person interface. And of course, person class can implement a lot of interfaces, iPerson 2, iPerson 3, iPerson 4. Let me to show you an example of association relationship. We know each student has a list of degrees. I want to add a class for degree. Each degree has a property of date, date of degree is better, date of degree, type of date time, and then add a property of type of degree. Because type of degree is constant, you can add a enumeration like every enumeration types. Enum of degree type here, and then add members, constant members like bachelor, like master, and then like PhD, for example. Here, and the type property in degree class is enum degree type. Is enum degree type. And now we have to relate student class with degree class. Each student has a property of degrees, degrees. Type is list of degree class is, let me do, okay, list of degree, and let me to show you association between two classes. Right click on the name of property, show as association or show as a collection association. Because the type of degrees is list of degree, I select show as a collection association. and you could see the association between two classes. Here's a very short overview of using UML diagram tool in Visual Studio, and I hope that a little help you to understand your ArcObjects model diagram better. And of course, you can export with a specific format, and I will open the diagram. Here is our diagram.